Hello everybody, welcome back to our third session for science. In the two previous sessions, we talked about the lesson 1, the meaning of motion, speed, the types of speed, the uniform speed, the non-uniform speed, and the last thing that we talked about it was the average speed. Motion, the first item in this lesson, we talked about it. We said that the motion is changing in an object's position or location through unit of time according to the position of other objects. And then we talked about speed. We said that any object moves, it must have speed. What the meaning of speed? We said that the speed is the distance which is covered by the object through the unit of time. And we can calculate it by the rule V equals d over t. And we tried to solve an example for this rule. Then we transferred to another item or another part that we talked about it in the second session, which was the types of speed. We said that we have two types of speed. What are these two types? We said that we have a type of speed called uniform or regular speed, and we have another type of speed which is called irregular or non-uniform. What is the difference between these two types of speed? It was the question of homework. What is the difference between them? We said that in the uniform speed, the object covers equal distance in equal periods of time. So the speed or the reading of speedometer of the car, speedometer is a device which used to measure the speed during moving. The reading of a speedometer is constant during all of travel. The second type is the non-uniform or irregular speed. What's the meaning of this type of speed? It means that the object covers equal distance but in unequal periods of time. Or the opposite. The object covers unequal distance in equal periods of time. Then we talked about the third topic or the third part, which was average speed. What the meaning of average speed? We said that the average speed is the total distances covered by the object divided by the total time taken during the travel. And we calculate it by the rule V dash. We said that the symbol of average speed is V dash to differentiate it from the original speed. So V dash equals total distances divided by total time. Of course, if the object moves with the uniform speed, for example 100 km/h during all the travel, and then we try to calculate the average speed, the answer will be the same. So the average speed is the value of average speed is the same like the uniform speed. But if the object moves with non-uniform speed or irregular speed and we try to calculate the average speed, in this case the value is different. So the average speed equals the uniform speed, but the average speed is different or doesn't equal the value of non-uniform or irregular speed. Today, inshallah, we'll talk about the last topic in this lesson, lesson 1, which is called relative speed. What the meaning of relative speed? Relative speed is the value of an object's speed. This value is determined or is measured by a person, not speedometer. For example, I stand on the road and there is a car moves in front of me with the speed of 80 kilometers. What is the speed that I can observe it for the car? I will see the car moves with the speed 80. Like speed observer or radar. It's a device fixed on the road to observe the speed of cars. Car moves with 100. Car moves with 80. In this case, the observer or the device or the person can observe the speed of the car with its value. But if there are two cars, one of them, for example, car A and car B, this car moves with the speed 100 kilometers per hour. And there is another car moves beside it with the speed 70 kilometers per hour. If there is a person rides in this car, here there is a person, and this person looks to the another car to observe its speed. What is the value of the observed speed? The person here in the car of 100 can see the another car which moves beside it with how much of speed? Here, the two cars are moving. So if you say that the person in the car A can see the speed of the car B with 70 kilometers per hour, it's wrong. Why? Because the two cars are moving together. But in this case, the person can see the speed of car B with the speed equals the difference between two speeds. He can observe that the speed of this car is 30 kilometers only. So the car B, the speed of car B is observed by the person in car A with the value of 30. But if there is a person stands on the road and this car, car B with the speed 70 kilometers, moves in front of him, he can observe the speed of this car with which value? With 70 kilometers. That means that we have one car moves with the speed 70 kilometers. Someone observes its speed with 30 because he is found inside a car, inside a moving car with the speed equals 100. But another person observes its speed with 70 kilometers. For the same object, there are two speeds are observed by two different persons. This is called relative speed. So the relative speed is constant or different? No, it's different. Different according to what? According to the position of the person. If he was inside the car, or he was on the road. So that we can identify the relative speed, that it's the value of an object speed determined in relation to an observer. This speed observed by the observer. It must not be the real speed. Maybe the real speed when you stand on the road, but when you was in the car, it's not the real speed. So the relative speed, it's the value of an object speed determined in relation to an observer. Okay, does the relative speed change or doesn't change? The relative speed changes, as we see in this example. The relative speed changes according to what? According to the position of observer. Let's see now how can we calculate the relative speed. In this example that we explain on the relative speed, we measure the difference between two speeds. But this way to measure the relative speed not always used during all of problems. It depends on the direction of motion. If the two objects move in the same direction, we have a way to calculate it. But if the two objects move in the opposite directions, we have another way. So we have two ways to calculate the relative speed. If the two objects move in the same direction, like this example, both of them move in the same direction, we measure the difference between two speeds, v2 minus v1, or v1 minus v2, the bigger one, if they move in the same direction. But when the two objects move in the opposite directions, in this case, we calculate the relative speed by making the summation, calculate the summation of the two speeds. For example, if these two cars move in the opposite direction, the relative speed for the person in any one of them can be calculated by making 100 plus 70, and the speed will be 170. Let's see some examples for the relative speed. Number one, an observer in a car moves with the speed of 120 kilometers. Car moves with the speed of 120 kilometers. And another car beside it in the same direction. Another car moves beside it in the same direction with the speed of 70 kilometers per hour. Calculate the relative speed. How can we calculate the relative speed in this case? We said that if the two objects move in the same direction, we make minus or subtract of the two speeds. So we make 120 minus 70, and it will equal 50 kilometers per hour. Another example. An observer in a car moves with the speed of 120, the same speed like the previous. And another car beside it in the opposite direction. In this case, the car moves in the opposite direction. How can we calculate the relative speed if the two objects move in the opposite direction? We make summation. So the relative speed in this case equals 120 plus 70, so it equals 190. Let's try now to solve these questions. Number one, the relative speed depends on space. Number two, the speed equals the A between the two speeds when the objects move in the same direction. Try to think. Number one, the relative speed depends on what? Position of observer. Number two, the speed equals space between the two speeds when the objects move in the same direction. In the same direction, that means the speed equals the difference between two speeds. Now write your homework. Number one, define relative speed. Number two, give reason. Relative speed changes and not a constant. Try to answer these questions. Thank you. See you later and goodbye.